All right. Good evening, students. All right. Welcome to one more session of your WC. That's nothing but as requested. You all asked me for a term one MCQs of biomolecules, right? Yes. We are going to almost do 69 MCQs, very important MCQs of biomolecules. And this 69 MCQs will include every line of NCRT. Okay, every line of NCRT is done in this. That's fine, students. That's great. And important thing, every question will be explained in a detailed manner. Everything will be in the detailed way. So please watch the complete video. My request, please take a notebook and note everything. Let's start off with the first question. I've made these questions from every line of NCRT. So please note it. The first question goes like this. What is the general formula for carbohydrates? Yes. So we very well know the general formula for carbohydrates is this. Yes. Nothing but you can also write it as CnH2O. Basically, instead of Y, you can write it as M also, anything rather. Here, what are we doing? So basically, suppose if I take C6H12O6 is a formula. Okay. Yes, students, here what does it contain? A carbon atom. Here N is equal to 6 rather. Okay, right. Now what are we doing? Here carbon is 6. So instead of N place, I'm going to write it as C6. Done. All right. And after that, in place of hydrogen, now what happened? Cn. Instead of that, I made it as C6. Done. Instead of hydrogen, the formula says 2 into M. So 2M is nothing but rather here M value also is, if I have to take 6 only, N and M, you're taking it 6. So what are you going to do? 2 into 6. That comes to H12. So again, oxygen atom is again M. M is 6. So oxygen is 6. Simple, students. So this is the formula, what you are writing. According to this, this is the general formula of carbohydrates. Got it? CXH2 H2OY. That's fine. Next question, that's great. Which of the following carbohydrates is not a monosaccharide? Yes, students. Remember, we very well know glucose, fructose, and galactose are all monosaccharides because they cannot be further hydrolyzed. I cannot hydrolyze them into units. But when it comes to sucrose, it is a disaccharide. So the answer here is which is not a monosaccharide, that's nothing but sucrose. See the diagram here. Sucrose is made up of two units. One is glucose molecule and one is fructose molecule. Glucose plus fructose molecule. Correct. That's the reason it is a disaccharide. And as it is mentioned, which of the following is not a monosaccharide? It is sucrose. Easy? Okay. All right. Next question, students. Carbohydrates or a carbohydrate which cannot be further hydrolyzed into simpler compounds is called what? Very good. If I see the classification of carbohydrates, students, just check. The first classification is monosaccharides, disaccharides, oligosaccharides, and polysaccharides. See here, monosaccharides have only one unit. That's why the monosaccharides cannot be further hydrolyzed. So the answer is monosaccharides. It cannot be further broken down. It has only one molecule present in them, for example, like glucose, fructose, galactose. Suppose if it is disaccharide, it can be broken into two sugar molecules, right? Sucrose can be broken into two, lactose into two, maltose into two. Like that, oligo can be broken into 10 sugar molecules. Polysaccharides to 10 or more sugar molecules. Correct. So the correct answer is which cannot be further hydrolyzed? Monosaccharides. And the examples are glucose, one is fructose, and one is galactose. So remember the monosaccharides where I can't break them further. That's fine. Very good. Next question. The reducing sugars. So basically, if I have to tell you, the reducing sugar can reduce aldehydes to alcohols. What are reducing sugars? Basically, they're trying to ask you. Okay, and then ferric salts to ferrous salts. Okay, chlorates to chlorides. Okay, Felling solution to cuprous oxide. Fine, students. So reducing sugars are those which can reduce. Remember, which can reduce Felling solution and tolerance test to the respective precipitates. Remember, I have given you an example. Observe, students. First, we will understand. Reducing sugars are those, yes, what are they going to do? They are going to reduce. Which one to which one? Suppose if I take tolerance test or tolerance reagent, they are going to convert this tolerance reagent into a silver precipitate. Done. If it is a Felling's test, if it is a Felling's test, this Felling's test, it's going to convert or it's going to form into a red copper oxide. See here, right? It's going to form into a red copper precipitate. So the substances which are going to reduce tolerance reagent, the substances which are going to reduce Felling's reagent, Felling's particular reagent are called as reducing sugars. So this is the answer. Easy? Perfect. Right. Next. Monosaccharides contain how many units? All right. So monosaccharides always, when you see the classification, see here students, see here. So monosaccharides basically are those which cannot be further hydrolyzed. But they're asking contain how many? When I start with the basic thing, actually the answer is this. Why? Because the basic monosaccharide is nothing but your glyceraldehyde. Okay, like that it can go from glyceraldehyde to next comes your glucose molecule. It can go till fructose molecule. It can go till galactose molecule, which have how many carbon atoms, students? 3 to 7. Perfect. So that's the answer. That's a basic thing. Done. Next question. The glucose or when glucose is reacted with bromine water, the major product formed. Okay, so glucose is reacting with bromine water. Check here, students. Whenever you're reacting with bromine water, it's nothing but an oxidation reaction. So what is it getting converted to? Glucose to gluconic acid. So remember, with bromine water, you're going to get gluconic acid. Easy. Next question. To convert glucose to saccharic acid, the reagent used is simple, students. Glucose to saccharic acid is used or it is converted by using a strong oxidizing agent. Strong oxidizing agent, that's nothing but nitric acid. So remember carefully, as I said earlier, if it is with bromine water, you will get glucose to gluconic acid. If it is with nitric acid, you will get glucose to saccharic acid. Shall we write that? Okay, let us write. With bromine water, I'll be getting glucose to gluconic acid. Okay, then if it is with nitric acid, I'm going to get glucose to saccharic acid. Is it okay, students? Remember this. Okay, sure, that's fine. Next question. Glycosidic linkage is an. What is meant by a glycosidic linkage? Yes, see here. Glycosidic linkage is an ether linkage. Why? Check the example which I have given you. See here. I have here a disaccharide, a maltose, which is made up of alpha D glucose and alpha D glucose. When they condense together, yes, there is removal of water molecule, and in that process, there is a formation of a bond that's nothing but an ether bond. Yes, ether bond. That's the reason the glycosidic linkage is an ether. Let us take lactose here also. You have two units. One is beta D galactose and beta T glucose. You are going to condense both of them and remove water molecule. And the linkage which is formed is nothing but ether linkage. So glycosidic bond is nothing but an ether linkage which is formed by removal of water molecule between two disaccharides, right? Or sorry, between two monosaccharides. Monosaccharides are combining, water is released, and they form a ether. Nice. Next question. Glucose fails to react with. Yeah, remember, students. Yes. So here, glucose is this one in which does not react with NaHSO3, but ketone is a compound which will react with NaHSO3 and form an addition product. What is the reason? Basically, in glucose molecule, it's going to form a cyclic structure, correct? Because of this cyclic structure, there is no free aldehyde group. No free aldehyde. That's the reason it will not react with NaHSO3. See? Next question. Yes, check here. Invert sugar is an equimolar mixture of what? So basically, students, the answer is alpha, so the D glucose and D fructose. Check this example which I have given here. So in an invert sugar, the example is sucrose. So what does it do? When you expose the sucrose molecule to basically plain polarized light, it will rotate the plain polarized light into, like it has different rotations. One is called the D glucose, one is called the D fructose. And when I consider this D glucose and D fructose net rotation or net specific rotation, yes, you are adding. Suppose if this is 52 degrees, okay, and if this is 92 degrees, right? So this rotation. Now what will happen? Both are D only. So here what am I taking? I'm subtracting both of them and divide by 2 because two molecules are formed. I'll be getting, or I'm getting an answer which is negative answer. I'm getting minus 20 degree is the answer. So because of this minus value, I call this as invert sugar. What do I call? I call this as invert sugar. Okay. So which one are the equimolar mixtures? D glucose and D fructose. Easy? Perfect. Next question. Dextrorotatory sugar present in glucose or present in fruits. Remember students, that's nothing but D-glucose. Glucose is a dextrorotatory sugar in which hydrogen is on the left hand side, OH is on the right hand side. Done. So the D-glucose is a dextrorotatory glucose form. Perfect. Next comes, what is this? The letter D in carbohydrate signifies what? Very nice, students. See this. So basically, this is a glucose molecule. In this, D is not either, if I have to tell you, like dextro, levo, not like that. Basically, it's the D and L is a configuration of this. Configuration of this. D sugar means, see that in D sugar, the hydrogen is on the left hand side and the OH is on the right hand side. So this is a configuration. In L sugar, you have OH on the left hand side and hydrogen on the right hand side. So this is the L sugar. So D configuration denotes the configuration or arrangement of hydrogen and oxygen. If it is in this direction, D form. If it is in this direction, it's called L form. Okay. Next question. The useful derivative employed in the identification of reducing sugar is what? That's great. That's nothing but ozone. What is this? See here. When your glucose molecule, okay, right, or when your fructose molecule, when they react with hydroxylamine, what is this, students? It is called hydroxylamine. When they react with hydroxylamine, the water molecule or whatever is there is eliminated. Okay. Yes, one hydrogen from here, one OH from here. So one more hydrogen from here, one more OH from here, like that, and you get a compound that is nothing but ozone. Ozone. Okay. So that's ozone is formed the reaction between your reducing sugar, right? You can go with your sucrose also, right? And those are going to combine with hydroxylamine to form ozones, which is a condensation product. This is a condensation product. Okay, done, students. Okay, done. The next compound is what? Right. So a monosaccharide contains an aldehyde group. It is known as, yes. If it contains an aldehyde, it is aldose. If it contains a ketone, ketose. Simple. Okay. Next question. Glucose and fructose are what? What are they? They are always functional isomers. Why? See here, students. In glucose molecule, you have an aldehyde group. In fructose molecule, you have a ketonic group. Yes, aldehyde and ketone are both functional isomers. Okay, formula is same. In aldehyde, it is C6H12O6. In ketone, also it is C6H12O6. Right. So only difference is functional group is different. That's why they are always functional group isomers. Okay, students, easy. Sure. Now let us see the next one. What is the function? And the function of glucose is to, you very well know, glucose, the whole body metabolism depends upon this. Correct? What is it giving us? It provides energy to us. Correct? That's perfect. Next question. Glucose is not A. What is glucose? Is not A. It is not a ketohexose, but it is an aldohexose. Correct? It is not, they asked me. So ketohexose is what? It is nothing but fructose molecule. Done. Okay, let us start with the next. Which of the following is a non-reducing sugars? Oh, wow. Just see, students, I said among all these, sucrose is a non-reducing sugar. Why? Why? Because non-reducing sugars are those which are, or basically glucose and other sugars are able to, like, reducing sugars are those which can reducing sugars are those which can reduce your um, Felling's reagent, or they can reduce tolerance reagent. That's what we said now. So reducing sugars are those which will reduce tolerance reagent and filling solution into the respective precipitates. Silver precipitate, copper oxide precipitate. Now they asked me non-reducing sugars. Non-reducing sugars are those, just like your sucrose, which is having, or it is made up of two different units. Two different units, right? It is made up of your glucose molecule and it's made up of a fructose molecule. It is combined together by an ether bond formation. That's why it is non-reducing sugar. And there is no free aldehyde group or free ketonic group to reduce tolerance test and tolerance reagent effects. You see? That's great. That's fine. So remember that. Next question. Glucose is also known as grape sugar. Okay, done. Next question. Reaction. Glucose uh, okay, we very well know this. It will not react because there's no free aldehyde. This it will not react because there's no free aldehyde. Schiff's reagent also same. Only thing it's with hydroxylamine. See the reaction with hydroxylamine. There is elimination of water molecule and glucose is getting converted to glucose monoxide, removal of water molecule, and this formation with NOH is called oxime. Oxime. Got it? Sure. Next question. The reduction of glucose to N-hexane, the reagent used is what? Okay. Whenever you want to convert glucose to N-hexane, the reagent which I use is HI. Okay, HI is a better leaving group. It will convert glucose to long chain or the normal chain hexane. Easy. Next question. The building unit of all proteins are what? Amino acids. See here, all the proteins, whatever are there, it is attached with an amino acid in a sequence. It is attached with an amino acid in a sequence. See these amino acids. So proteins are sequences of amino acids. And next question. Essential amino acid among the following. See students, in the body there are two types of amino acids. One is which is obtained through food. Okay, this should be taken. This is from food. This is from food. This is synthesized by the body. So essential are which are required. You have to take it from the food. Non-essential amino acids are body itself synthesizes. So they've asked me essential amino acid among the following. See here, tryptophan. Tryptophan is essential amino acid. Glycine is non-essential. Alanine is also non-essential. And if I have to take proline, also is non-essential. So 1, 3, 4 are all non-essential amino acids. And here 2, whatever is there is an essential amino acid. Remember this table, very important. Next question. The amino acid which cannot be synthesized in the body must be supplied through diet. Which one you have to supply through diet? Always remember the through diet we should always supply essential amino acids. The list are these. So non-essential the body only synthesizes. Body synthesizes these. Okay? Okay, that synthesizes these. Perfect. So essential amino acid should be taken through the diet. Next, the acidic amino acid. So remember students, when they say acidic group, check for aspartic acid, glutaric acid like that. So aspartic acid is an acidic amino acid. Next comes, what are the basic amino acids? So for you to remember, I have got one table. Remember. So amino acids are classified into acidic amino acids, okay, neutral acidic amino acids, basic amino acids, and neutral amino acids. So they're asking basic amino acids are what? Yes, students, observe carefully. Basic amino acids are lysine, yes, arginine, yes. These are basic amino acids. So remember this table. This is important. Okay. Now let us check alanine and glutamic acid. It is coming under acidic amino acid. Correct. So let us check proline. Okay, glycine is coming here. Alanine, glycine. Okay, proline. Where is it coming, students? So like that. To remember the table, to remember, check, learn the table. Next question. The protein which controls the amount of sugar in the blood. Yes, hemoglobin. Easy. Next, which of the following contains nitrogen? Where nitrogen is present, it's proteins. Check, students. Proteins are going to combine. Okay. Alpha amino acids will combine with one more alpha amino acid, and in between these two there is elimination of water molecule, and you get a bond called peptide bond. So this is your peptide. This is your alpha amino acid. This is your alpha amino acid, and they are going to combine both and eliminate water molecule, and they are going to form peptide. Now they're asking nitrogen. Where is nitrogen present? It is present in proteins. Perfect. Okay, right. Now which of the following is the simple protein? Now simple, students, or check. This is your basic albumin. Okay, this is your albumin molecule. This is your globulin molecule. This is glutamine molecule. All these are proteins which have globular structures. All proteins, these are proteins which have globular structure. Right. Next question. Proteins are polymers of amino acids. Which of the following is not a protein? Yes. Remember, students, DNA is the only thing which is not a protein. Why? This is a nucleic acid. Okay, done. Next question. Cheese is what? What is cheese? It's a globular protein. It is conjugated protein, denatured protein, or derived protein. It is a conjugated protein. Remember, you can check it. It's like the structure is complex, so I've not bought that. So it's a conjugated protein. Next question. Which of the following is not an amino acid? Oh, right. Glycine is an amino acid. Alanine is an amino acid. Histidine is an amino acid, but benzidine is a type of dye. It's a dye. Yes, so this is the answer. It is not an amino acid. Next question. Proteins are what? What are they? Yes, the answer is polyamides. Check the example I got here. Alpha amino acid combines with one more alpha amino acid, one more alpha amino acid, one more alpha amino acid. Everywhere there is elimination of water molecule, and you get amide linkages. This is all amide. This is all amide. This is all amide. Okay, got it? Yes. So what is this? Like that, 1, 2, 3, 4, like that, you'll be getting amides. So it is nothing but polyamide group. Polyamide group. So amino acids combine in a sequence, and they form, what do they form? They form amide linkage. Done. That's nothing but polyamide. Next question. Protein synthesis in living cells is also known as translation. Easy. Next question. Proteins are condensation polymers of what? Yes, I already said. Alpha amino acids combine together by the elimination of water molecule. They are going to form a peptide bond. Peptide. Easy. All right, that's great. Next comes pH value of a solution in which a polar amino acid does not migrate under the sequence or the influence of electrical field is called isoelectric points. Means that but there's one particular pH where there is existence of Zwitter ion. Zwitter ion. What is Zwitter ion? Where both the positive charge and the negative charge exist in the molecule. Right. Now, if you increase the pH, if you decrease the pH, see here, if you are increasing the pH, it will go to your basic. If you increase the pH, it will go to the basic medium. If you decrease the pH, it will go to the acidic medium, right? So what is this point called? This point is called isoelectric point. So this Zwitter ion formation happens at isoelectric point, where it will not go to any of the electrode. It's stable there only. It is neutral. Its Zwitter ion is neutral form. It will not go to any of the electrode. Done. Next, which of the following is a fibrous protein? That's great. Check, students. Fibrous. Observe. This is hemoglobin. This is globular. This is albumin. This is also globular. Okay. Then this is keratin. Got it? This is fibrous. This is enzyme. This is also globular. Got it? So among everything which is a fibrous protein, it is nothing but enzyme is the correct answer. Sorry, students. It is keratin is the correct answer. Sorry, keratin is the correct answer, which is fibrous in nature. Got it? Yes. So let me take this. I'm sorry for this. Right. So what is the answer, students? Keratin. Keratin is a fibrous protein. Okay. All right. Shall I take it? Okay. Let me take this one's camera. Let me erase this so that it is not clumsy for you all. Okay. Let me. This is fine, students. So that's the thing. Sorry for that. Okay. So keratin is a fibrous protein. Let me fix my camera. Okay. Done. Right. Next question. Which of the following is a globular protein? Yes, just now we have seen myoglobin of hemoglobin. Remaining all are fibrous, fibrous, fibrous protein. Next question. The structure or the destruction of biological act nature and to biological nature and activity of a protein by heating using chemical reagents is called denaturation. Correct? Right. Next question. The base pairs present in RNA are what? Yes. Check, students. In RNA, basically in DNA, when I take, you have adenine, guanine, adenine pairs with thymine, guanine pairs with cytosine. Yes. Now, in case of RNA, what happens, students? Adenine is there. Perfect. Yes. Instead of this, here, what is happening? Adenine is pairing with thymine. Guanine is pairing with cytosine. But here, what happens? Adenine is pairing with thymine. Instead of your guanine, you have uracil pairing with cytosine. So uracil with cytosine. Easy? Done. Next question. The AMP sequence is, what is AMP sequence? AMP sequence is nothing but adenosine monophosphate. What is it formed? It is formed by a combination of phosphate bond, formed by a combination of a nitrogenous base. It's formed by a combination of a sugar molecule. Okay, phosphate bond, nitrogenous base, and a sugar molecule. Or if you go like this, phosphate bond, sugar molecule, and a nitrogen base. So I'll go with third option. See, next question. Which one of the following is not present in RNA? Okay, done. As I said just now, thiamine is not present in RNA. Okay, here what did we write? Did we write this? Okay, so here basically let's check once. Here what did we write? Here check here. If I go here, in RNA, adenine, guanine, cytosine, uracil. What is missing? Thymine is missing. Thymine is not there. So what mistake did we do here? Here, adenine is not there. Instead of it is uracil. So guanine is there here. It is pairing with C. Okay. So instead of thymine is here. Thymine is missing here. That's what we have written. So that's a mistake which we have answered it. So please check that. Sorry for that. And here, in case of RNA, once again, let me write. A is here, T is there, G is there, C is here. This is in DNA. A is here, uracil is here, G is here, C is here. This is in RNA. Okay, done. Easy? Sure. Thymine is absent. Next question. Which of the following base pairs is not present in DNA? Oh, easy. That's nothing but uracil. In DNA, what do we have, students? We have A, T, G, C. Correct? Done. What is absent? Uracil is not there in this. Next question. Nucleotide is made up of what? Okay. Check here, students. Nucleotide is something which has three units. One is sugar, one is base, one is a phosphate unit. Got it? So sugar, base, and a phosphate unit. Nucleotide means how many units, students? Three units. Okay. Right. Side means two units. Tide means three units. One, two, three. Done. Next question. In DNA, the complementary base pairs are what? Okay, it's easy. It's nothing but option B. We have seen just now. ATGC. Correct? ATGC. Okay, done. This is your complementary base pairs. This is in DNA. Okay. Next question. The structure of DNA molecule. Perfect. I very well know. It is nothing but a double stranded DNA. It's a double helix. Correct? RNA is single stranded and DNA is double stranded. RNA is single stranded, single helix. Okay. Right. Next question. Thymine is held by two hydrogen bonds with the base. Yes. Which base? So thymine, basically, yes, students. Thymine always pairs with your thymine, always pairs with your adenine. Correct, my students? So here, adenine is pairing with thymine with how many hydrogen bonds? Two hydrogen bonds. One and two. Right. So two hydrogen bonds. So A will pair with D. Easy. Next question. The number of nucleotide pairs in one turn of DNA helix. In one turn, there are 10 base pairs. Remember, students, 10 pairs are there. Okay, so 10 is the answer for this. When you count like this, 10 base pairs are there. Okay, next count. The nucleic acids in the nucleic acid, the phosphate ions bonded with sugar are located in. Okay, it's nothing but 5 prime 3 prime location. Yes, 5 prime, you take a turn, it's going like this. 5 prime 3 prime mutation is where? So 3 prime 5 prime mutation is where? Right, done. So next question. The difference of simple base pairs in DNA causes change in amino acid sequence. Remember, students. Next, change in amino acid sequence leads to mutation. Okay. Purine derivative among the bases. Purines is nothing but guanine. Okay. Purine pyrimidines you have, no? Yes, it is nothing but guanine. So there are purines and pyrimidines in that guanine. Next, to become a carbohydrate, a compound must contain at least, see here, to become a carbohydrate, the compound must at least have 3 to 7 carbon atoms. Check here. The basic compound is glyceraldehyde 1, 2, and 3. Easy. Next question. The number of nitrogens present in glucosone. Okay, what is osazone formation? When your glucose molecule combines with phenyl hydrazine, by the removal of water molecule, there is a formation of a compound called glucose. So, how many nitrogens are present, students? See here. One, two. Okay, this is here. This is osazone. So, glucose if I have to take one, two, three. So, four is the answer for the first one. Okay. Okay. Right. Easy. Next question. The major component of sugar present in honey, invert sugar. Remember that. Next, the formation of furanose structure of fructose involves which compound? Okay. So in furanose, if you want the furanose structure to form, it will form between C2 and C5. Why? Check here. When during cyclic structure, the C2 carbon and the C5 carbon are forming a ring or a cyclic structure. Right? So together to form a structure called fructofuranose structure. So it's a condensation between C2 and C. Next. And in glucose, it is between C1 and C5. Next compound, next question. Glucose gives silver mirror with ammonical silver nitrate because it has, yes, see here. Glucose is reacting with your ammonical silver nitrate. It's nothing but Tollens reagent. When it reacts with Tollens reagent, it is going to precipitate a silver mirror precipitate, silver precipitate. Because of which presence? Because of aldehydes are getting converted or they get oxidized to acids. Okay, aldehydes are getting oxidized to acids. That's perfect. So this is because of the presence of an acid group, aldehydes to acid. So that is which one? Aldehyde is. Because of the aldehyde only, you're getting the conversion. Next, which of the following represents anomers? Okay. Anomers means what? Let's see. There's one combination here, right? CHO is here, CHO is here, H is here, H, OH and H. Okay. The remaining everything same, same. All right. First combination, it is varying in C1 carbon. Let's take one more option. If I see the option B, here also C1 is changing. Okay. C2 also is changing. Okay. Done. Let's see the third one. Here in this case, what are you seeing? C1 is changing and it is forming cyclic structure. Okay, then let us see this. In this case, also C1 is changing, it is also forming cyclic. C2 also is changing, which is forming cyclic. Now, which is the anomeric form? Okay, they're asking me which is the anomeric form. So always remember, students, if somebody asks you what is meant by anomer, check the answer. Correct answer is C. This is the answer. I'll tell you why. Always remember, anomers are those which will differ. Okay, where do they differ? They differ in configuration. Okay, which configuration they differ? They are going to differ the configuration at hydroxyl position. Okay, hydroxyl position is in which carbon? You are going to check at C1 carbon. At the C1 position, you're going to check for the C1 carbon. You check for the hydroxyl group. And important thing here is they are going to form alpha and beta form. Okay, and that alpha and beta form, they should differ at C1, and it should be a cyclic structure. So cyclic structure, condition 1, it should differ at the alpha position. Condition 2, at C1 carbon. Condition 3, change of the hydroxyl positions. That's the thing. So this is the option. Change in the C1, cyclic structure. I'm writing change in C1, cyclic structure. Next, what do you say? Alpha beta formation. This is what is the anomaly. Okay. What are you changing? Checking for OH group change. Done. Next question. The three cyclic structures of monosaccharides are given below. Which of these are anomers? Check, students, careful. I told you the conditions. You should check for cyclic structure. You have to check for C1 carbons. Yes. C1 and 2. The correct option is A. Why? See here. This is C1 carbon. They are shifting at H and OH is getting shifted. Remaining all are same. Perfect. So this is where what is important. So anomers, C1 carbon, check. There should be a shift of this H and OH bond, check. There should be an alpha beta formation, check. And important thing, they should be cyclic structures. Done. Next question. Optical rotations of some compounds along with structures are given below. Okay. Which will have deconfiguration. Okay, now see the answer, students. Basically, deconfiguration means you are going to compare with a glyceraldehyde molecule. Okay, right. So here the answer is 1. In deglyceraldehyde, compare the H and OH with your yes, which one? H and OH of the fifth carbon, H and OH of the fifth carbon, C5 carbon. So if the fifth position H and OH, here's the C2 carbon, and here C5 carbon. If the H and OH are on the left hand side, then it is nothing but they have deconfiguration. D. Got it? So again, glyceraldehyde with H and OH on the right hand side on the C5 carbon, then it is called glyceraldehyde. Is it okay? Done. Next question. What is the product of the following reactions? Now, see here, it's a strong oxidizing agent. I said something. If it is a strong oxidizing agent, glucose gets converted to which compound? Gluconic acid. No, wrong. It is nothing but saccharic acid, because with bromine water, you are going to get gluconic acid. What is saccharic acid, students? Yes, saccharic acid is a fourth one where you have two COH groups at either side. Gluconic acid is with bromine water. So glucose with gluconic acid is with bromine water, and glucose with saccharic acid is nothing but nitric acid. All right. Next, let us see the next question. The term anomers of the glucose refers to. I said just now. Those are the isomers at C1 position. Right. Next, D-glucose reacts with hydroxylamine and yields oxime. What is oxime structure? Easy. This is your oxime structure. Yes. So what is the difference here? Check. Everywhere CHOH is there, but in the first carbon OH and H, wrong, right? And in this case OH and H, wrong. All right. In this case HOH, right? Okay, let us see this here. Also HOH is there. What is the problem with this? Any change? This is the problem, students. See here, they have changed the structure here, correct? So this is also, this is the perfect structure for sun. Got it? Next question. In Harvard structure, the alpha anomer of glucose contains the OH group. Okay, this is a Harvard structure of glucose where we have drawn the structure, we have drawn the cyclic structure and drawn the Harvard. Now they are asking the in Harvard structure, the alpha anomer. Okay, this is the alpha anomer contains OH. Where does it contain? See here. OH is below the plane of the ring. Perfect. Second option. In beta, it is above the plane. In alpha, it is below the plane. Next question. Al- Alpha D glucose and beta D glucose differ from each other due to difference of carbons with respect to, okay, we have alpha D glucose, we have beta D glucose. What are the differing? Remember, students, they are going to differ in terms of configurations. Why? You check here. In this case, hydrogen and OH are present on the left hand side. In this case, OH and H are present on the right hand side, correct? So in case 1, H on the left hand side, in case 2, OH on the right hand side. So remember, always T configuration, D denotes the chain configuration. Okay, so that too, H on the left hand side and OH on the right hand side. Right. So this is what is from my end. Thank you so much, students. Remember, WOC is always with you all. Okay, always with you all. Right. And important thing, 1600 plus videos are done for grade 10, 11, 12, J and D. So my request is, please subscribe to the channel. Please share the video. Thank you so much, students. I'll come back with one more video. Thank you. Take care. Bye-bye.